coming on. That's all I've been waiting for all day. Yes.
So now, do you want to set it here?
No, it works.
Okay, you got it written down? Let's go, come on.
Thanks.
What are you doing? Come, wait for you again. Come on. You must make your S like mine.
I can't.
If I wrote my own language, that would be a sate.
A what? Sick.
Sate.
Sick.
S-E-I-G-H.
What?
Why would you make that more complicated?
Why wouldn't you?
It looks like the Disney ass. 5 minutes. Mr. Haugh, it
Okay.
looks like the Disney ass.
You have a calculator, I hope. What I would like you to do with your calculator, you can pick the mode, I don't care. You can be in radian or degree mode. And you can pick the angle. You can make the angle any size you want. I just want you to pick any number, make sure it's the same number, plug it into this little expression right here, and see what happens. Just pick a number, plug it into that expression, see what happens.
What?
It's gonna
Like
equal
the sine squared of 28
Doesn't it
plus the
equal
cosine
1?
squared of 28. I think you'll know if you're right.
It equals 20 and it equals 1.
Don't you have to square the whole thing?
You just do it like that.
Yeah, we already did this.
I know.
Yeah, we've been through this.
Been there, done that.
Why don't you give me a
Yeah, I don't know.
I don't know how to.
I want my picture. I think I did it. Do you need identities?
No, I don't.
Oh, I missed parentheses.
Okay,
I want Jazz hands.
Grace, what'd you get?
I got one.
Mather, what'd you get? Meffertless, what'd you get? Quit rounding crap off. If there's no rounding going on, what would you have gotten? Attaboy. Alright, so no matter what angle you pick, you're supposed to get 1, and if you're thinking, hey, I think I've done this before, we did. Because we had the Pythagorean identities way back in the beginning of chapter 4.
And I didn't know them.
I know, now we have to actually know them, learn them, memorize them, and prove them.
Wow. Okay, never mind.
Yeah. Did we do the proof way back in the beginning?
No.
We didn't?
Alright.
Oh, we did.
No, we did.
Oh, yeah, we definitely did.
We
I
might
thought
have
we
done
do
it
it.
for this one, but we
I'm
didn't do it
almost
for the other one.
Okay, so quick refreshing. This is what is called an identity. Sine squared plus cosine squared always equals 1, which makes it an identity. Tomorrow you're going to get a big old sheet full of identities, and we're going to have to memorize them all, but I didn't want to scare you too soon in the chapter. So we figured we'd just start here with sine squared plus cosine squared equals 1. If you go back to the beginning of chapter 4, on the first day of chapter 4, we used x's, y's, and r's to define a trig function. And on the second day, that's when we brought in o's, a's, and h's, all that kind of jazz. And you are more comfortable, most likely, with o's, a's, and h's, although it really wouldn't matter. So if I had an angle here, no matter how big the angle is, it doesn't make much of a difference. I've got a radius, I've got an x coordinate, and I've got a y coordinate. And that can be anywhere in the circle, it doesn't make any difference. Tell me about these, x squared plus y squared.
Equal R
It's
squared.
always going to equal r squared. You have a Pythagorean theorem, you learned that many moons ago. Alrighty. How about using its definition, what is sine of theta?
Y over R.
Y over r. So it's supposed to be y over r squared. If I go y over r
Yeah, we definitely.
squared. And then another name for cosine? X over r squared. And what I'm doing here is I'm going to put a question mark there, like, is that really always going to equal 1? That's what I'm trying to prove. We took pre-algebra. When you square a fraction, what gets squared? Both, top and bottom. So this is going to be a y squared over r squared plus an x squared over r squared. And yay or nay equals 1. A little bit of convenience there. We have common denominators on the left side. So we can make that a single fraction and call it
Y squared plus x squared over r
y squared plus x squared over r squared. May or may not equal 1. we did a little front loading on this proof way back here, like a minute ago. You told me that x squared plus y squared equaled r squared. Is that still true?
Yes.
So I make a little substitution, x squared plus y squared equals r squared. Now I've got r squared over r squared, also known as
It's still
1. Now I have 1
Hear that, Allie?
equals
It's magic.
1. That deserves a smiley face.
It does.
I feel like it makes the fraction the same. We need another smiley face.
It's no longer balanced.
Yeah. There.
One smiley face and smiley face.
Just put a mouse underneath the 1 equals 1.
Or then you can make that.
Ah, you need to check it. What is that?
It's the nose.
It's a weird nose.
It's like the forehead, wrinkly forehead.
This is my nose.
Okay, so that is an example of a trigonometric proof, which is cool just because it has the word trigonometric in it. It's kind of like the word
Trigonometric.
arithmetic. Arithmetic's just a cool word. It's spelled like arithmetic. But you know, it's arithmetic. Trigonometric. All right. So in section 5.1, you'll notice your auto notes say 5.0, not 5.1. 5.1 is trigonometric proofs. And trigonometric proofs always have these lovely things with equal signs. And the goal of a trigonometric proof is to show that the two different sides are equal to one another. But you can't really show that the two sides are equal to one another if you're not very good at simplifying things in the first place. So I have invented section 5.0, which is kind of a precursor to 5.1. We're going to learn you how to simplify this stuff first before jumping into proofs. And in order to simplify them, there are 3 Pythagorean identities with which we need to be familiar. This is the first of the 3, that sine squared plus cosine squared will always equal 1. And that's going to be true, and it's going to be used a gazillion times between now and whenever you graduate. So if we have this, that sine squared plus cosine squared equals 1, that means we've got different varieties of that as well. Because they are equal, we could do things like sine squared equals 1 minus cosine squared. That's now going to be legitimate. Or we could do things like sine squared minus 1 would be equal to what? Negative cosine squared. So these also count as truisms. There's a fancy word. Because this is true, we can now play algebra games with it. If we didn't know that these two were true, if we didn't know that this side and this side were equal to one another, then I couldn't be doing these kinds of things. Because the laws of algebra say you can only do the same thing to both sides of an equation if they're actually equal to one another. If they're not, then that doesn't make any sense. So that's trigonometric proof number 1. There are a couple more we're going to do tomorrow, and then we'll dive into section 5.0, which is not a very long section, which is a good thing because we don't have a very long class period tomorrow. That's right, isn't it?
Right.
Yeah.
Yeah.
Is tomorrow the one where we go 4, 6, 7 in the afternoon?
Yeah.
We won't have a long class period on Friday either. We have a class.
Yeah, there's cut class on Friday.
That actually works out okay. All right, so here's what I'm going to ask you to do as you walk out the door. Hand to me your 2 tests. I don't need anything else back, but hand me your 2 tests. The 10th graders that I was asking if you would stick around, that'd be awesome. Those of you that are AMC testing tomorrow,
Good luck, Allie.
7:45 in the